So this question is a diagram question. We know that because of the table that's provided as well as the graph that's provided. So the information in the table and the graph in this case are actually the same, where we have minutes after injection, so that's our first column there, but also our x-axis on the graph. And then our second column in the table is penicillin concentration in micrograms per milliliter, which is also our y-axis for the graph. So the information provided here says when a patient receives a penicillin injection, the kidneys begin removing the penicillin from the body. And we see that, right? We see that the amount of penicillin goes down over time in both the graph and the table. The table and graph above show the penicillin concentration in a patient's bloodstream at 5-minute intervals for the 20 minutes immediately following a one-time penicillin injection. Okay, so no surprises there. It is pretty much as we saw in the graph and table. So question 38 says the penicillin concentration in micrograms per milliliter, so same unit that the graph and table are in the patient's bloodstream T minutes after the penicillin injection is modeled by the function P defined by, and I'm going to write that down, P of T, right? So penicillin as a function of time is equal to 200 times B to the T or time divided by 5 power. If P approximates the values in the table to within 10 micrograms per milliliter, what is the value of B rounded to the nearest tenth? So we're just trying to solve for B. Okay. And the question is telling us we can use the table. So we know that we can substitute, right? I know that, hey, I can choose any of these values here that I'd like. And maybe I'll choose a couple just to prove that to you here. But really, this table should give me some good values here for B's. And the B value is going to be rounded. It's not going to be exact, but it'll be good enough for what we're looking for here. So let's say we chose this row here. Now, what does that row there tell me? That tells me that when T is equal to 10, so P of 10, when T is equal to 10, then the penicillin concentration is equal to 118. So I'm going to use that information and plug it into my model. So instead of P of T, I'm going to write 118, right? So I'm replacing P of T with 118. So 118 is equal to 200 B to the, instead of T over 5 power, is going to be 10 over 5 power. So I'm replacing the T with a 10. So I continue with that. 118 equals 200 B to the second power because 10 divided by 5 is 2. I can then divide both sides here by 200. So I throw that into my calculator and I get 0.59 equals B squared. And then I square root both sides here, and I get B is equal to 0. Looks like I'm having 0.7 something, but it wants me to round B to the nearest tenth, so that's going to actually be a 0.8. So there's a solution for me. And let's just try this one more time. Let's say I chose this row here instead. So that tells me that P of 20 is equal to 74. So now, again, let's replace the P of T with 74. And then we still have our 200B to the T over 5. So instead of T over 5, it would become 20 over 5. So I'd have 74 equals 200 B to the 4th power, because 20 divided by 5 is 4. And then again, I can divide both sides by 200. So in my calculator, 74 divided by 200 is equal to 0.37. So I have 0.37 equals B to the 4th. And then I can do the 4th root of both of these. So in my calculator, let's see, 4th root of 0.37. So I'm also getting B equals 0.8 for that as well. Okay, so those are two things. You could try 15, you could try 5, you could try 0. I don't think 0 is going to be all that helpful for you because b to the 0 ends up being 1, right? So that's actually not a good one to try. But any of the other ones you could try, and you should get this exact same answer for b.